So again, the introduction to vectors is on trigonometry. So we deal with a right triangle. There's an angle this 90 degrees. And opposite to that 90 degrees is the hypotenuse. And there is a theta here as defined. And opposite to this theta, we can call this as h sub 0, or the length of side opposite the angle theta. But you can call this arbitrarily any variable. So h0 there. And the adjacent to theta, take note, when you say adjacent, this is here. Length of side adjacent to the angle theta is h sub a, or you can call this whatever variable you want. Okay, so for trigonometry, for the right triangle, we have to define the three trigonometric functions known as SOHCAHTOA. So it's known as SOHCAHTOA, shortcut for the mnemonics. SOHCAHTOA, this one. Okay. Why SOHCAHTOA? Because for sine theta, it's opposite over hypotenuse. That's so. Okay. And cosine theta is adjacent over hypotenuse. So like, for example, you define theta here. When you say adjacent over hypotenuse, is this one, HA over H. And then tangent theta, it's TOA, it's opposite over adjacent. So tangent theta is H sub O over H sub A. So there. So you do define H as hypotenuse, H sub 0 as the opposite side of theta, and H sub A as the adjacent side of theta. Pero if you define another angle here, let's say alpha, kung alpha here, lahi na sa diyang opposite, lahi na sa diyang adjacent. So it depends on what angle you are particular or you refer to. Okay, so that's an intro to trigonometry. Kinira tulo ka trigonometric functions that we commonly use in vectors. Okay, so if we proceed, okay, if we use this trigonometric function, like for example, this is a math example. On a sunny day, a tall building casts a shadow that is 67.2 meters long. The angle between the sun's rays and the ground is 15.0 degrees, as shown in the figure. Determine the height of the building. So you can determine the height of the building in this case because you can have the angle theta here, and of course, between the height of the building and the horizontal with the ground is your 90, and your theta is here. So if you want to determine the height of the building, so you can use this adjacent side because it is known 67.2 meters long. So this is the adjacent side to this of the theta, and the opposite to that of the angle is your opposite side. So if you use the trigonometric function nga naa ma-involve ang known, and so that usaray unknown, so we use tangent because we don't know hypotenuse. So you cannot use the cosine and the sine, it involves hypotenuse. So we will use tangent because they involve the adjacent, the opposite side, when the opposite side will give you the height. So therefore, tangent theta, the theta is 50 degrees, is opposite is h naught over HA. And HA is known, so this is known, this is theta is known, so you can solve h naught. And h naught therefore is HA times tangent theta, just cross multiply, and 67.2, and then press tangent 50 in your calculator. Please take note in your calculator dapat na degree mode kay na any different angle expression like radian mode and gradient mode. So degree mode because we are using degrees. So dapat nakadeg ang inyong calculator because if it's radian measure like 2 pi r is 1 radian, like 2 pi rad is 360 degrees. So the conversion is, but anyway, you have trigonometry later in your math. One whole revolution of a circle is 2 pi radian. That's equal to 360 degrees. And from that, you can use that as conversion factor. But anyway, it's an introduction. We'll use the degree first. So you can determine now the height of the building. So that's how to use this trigonometry. Okay? Okay, so next is, what if you want to know the angle? If you want to know the angle, you use the inverse angle, like inverse sine or inverse trigonometric function. So you have the inverse sine, inverse cosine, and inverse tangent. So what does it mean? So it means that what the theta equals the angle whose sine, okay, for sine is h naught over h, or the theta whose cosine is h over h, or the theta or the tangent, the theta whose tangent is h naught over ha. When you say theta, it gives the angle. So here, you ang pasabot aning sine to the power negative 1 is not reciprocal na 1 over sine. It's actually the inverse trigonometric function that will give you the angle. So that is why theta equals the angle whose sine is h naught over or h sub 0 over h. So that's how to interpret that one. Imurang i-inverse. Di ba, sin theta to ganina is equal to h over h. So kung magkuha kag theta is sine inverse or inverse sine h naught over h. So this is very important in trigonometry or in our vector computation later. Okay, next. Pythagorean theorem also. Pythagorean theorem is very important in vectors. So when you say Pythagorean theorem, it's applicable to a right triangle when you have the hypotenuse, the longest side, wherein the longest side is c squared is equal to a squared plus b squared. You're familiar with your math, right? So in this case, it's h squared, h sub 0 squared, where in h sub 0 and h sub a are the legs. So both are squared. So to find for h squared, to find for h, use square root both sides. So it will be h is equal to square root of h naught squared plus ha squared. Okay, so and this can be used also to determine the resultant vector later in our computation. So this another math concept Pythagorean theorem, magbalik-balik ni siya in vectors. So remember this. Okay. So scalars and vectors now. So scalars is one that is described with a single number or magnitude only, but it could have units like temperature, degree Celsius, like Kelvin, or mass 85 kilogram. It could have units, but not with direction. While vector quantity, both magnitude and direction, and the characteristics of a vector in the book, it's usually with an arrowhead that will give you the direction. And towards the positive x is positive, towards the positive y it's positive, or downward is negative, and so on, like that. The sign will give you the direction. Okay, so that's vector quantity. And the first step in our vectors is vector addition by graphical method. So dili pa ni computational, graph pa, measure or ruler, and using a graphing paper. So I'll be having an activity, or if you check your lesson guide, using a graphing paper and a ruler. So the first method is tail to tip method. So what is this? On a diagram, draw one of the vectors, call it D1 to scale. So nakay X and Y, no? Like ni walk siyang person towards east. So from origin 0, so let me annotate ha. Okay. So the first vector is this. Okay, kini. D1. This one, the D1. Okay, from origin to 10 kilometer east. Okay, that's D1. So you draw it to scale using your ruler. So when you say to scale, you can, let's say, 10 kilometer is equal to, di man ka makadrawing o kilometers imong paper. So you scale it to 2 centimeter. 10 kilometers is to 10 centimeter, or 1 kilometer is to 1 cm, so that you can draw it in the graphing paper. And of course, you can convert it later towards the kilometer. And then next, draw the second vector D2 to scale, placing its tail. So ang tail sa second vector to the tip of the first vector. So ang tip sa arrow, di ba? Tip ni sa first sa D1. Ang tail po ni sa D2. So they are connected. So i-draw ni mo diha. That's why the term is tail to tip method. The tail of the second vector drawn to the tip of the first vector. So kana siya. So this is the first vector, and this is the second vector drawn tail to tip method. Then after, the arrow drawn from the tail of the first vector to the tip of the second vector represents the sum or the resultant. So this is now the resultant, this one. So mo na ni resultant, mag-drawing na ka, i-measure ni mo ruler, kung pila na siya ka centimeter, and then i-convert na balik to kilometer. You know dimensional analysis man, no? So like ibalik ni mo kilometer, imong conversion factor is 10 kilometer over 10 cm. Kaya imong ma-measure diri, like let's say, ang imong ma-measure diri is let's say 4 cm. 4 cm multiply sa conversion factor, you can cancel centimeter. And of course, you can go back to the original unit, the kilometer. Okay, so that is just a graphical method. No need to compute. You just draw to scale and connect tail to tip method, tail to tip fashion, and then connect the tail of the first vector. So from the tail of the first vector to the tip of the last vector, that will give you your resultant vector, the R. So mo yung resultant vector, and you have noticed that they are with arrows on top to mean vectors. Okay. So that's tip to tail method. So easy, right? So you need graphing paper, ruler, and protractor if you have angle later. So what if the vectors are added in reverse order? If we reverse na to, like we draw dito first, di ba? The dito is here. So we can draw dito first. So first, atong gidraw ang dito. So this one, the dito here, gidrawing. And then we connect the tail of the D1, ang second vector to i-draw, to the tip of the first vector. So diri, okay, connect. So D1, you draw it. And then, to get the resultant of the two vectors, you draw the line from the tail of the first vector to the tip of the last vector. So there, and you will notice that they are of the same magnitude if ang order gibali. So therefore, addition of vector is commutative or not commutative. When I say commutative is pwede ma-reverse. So pwede siya ma-reverse ang order. Okay? So that's for vector addition using the tail to tip fashion. Okay? So next, if we have three or more vectors, pwede ra gyapon. If this V1, this V2, take note na mag-drawing kag vector scale po nimo daw wala kay ruler. If V1 inani this much and V2 mas taas, so you draw it like that. And then V3 is in that direction. So what if to look a vector? So you can still do tip to tail or tail to tip fashion also. So like V1, you draw V1. So V1 is here. um, you can draw, yeah, like V1 is this one, then you connect to V2. Yeah, the V2 is here, and then V3. So still you can connect from the tail of the first vector to the tip of the last vector, and this will give you the resultant vector. So you will measure it using a ruler, pila ni siya ka centimeter, and then you measure the angle, mag-drawing ka diha og imaginary nga axis with a protractor. So pila angle niya below x-axis or pila angle niya with respect to y-axis, negative y-axis. So you can do that using a protractor. Ruler lang and protractor. Any questions so far? Any question? Tail to tip?
Wala.
Wala? Klaro ra? Okay. So let's proceed. Dili man math. Dili ra. Drawing raman siya. Okay. And next is parallelogram method. In parallelogram method, it's the second graphical method in adding vectors. So some books will say polygon method or parallelogram method. So if we are going to review, tanawa, that tip to tail fashion or tail to tip. So V1, gidraw ang V1 first, then gi-connect ang V2, then get the resultant. So that's the tail to tip fashion. We are done with this. So do not mix up these two method ha, because usually the mistake is you mix up ang two methods. So tail to tip kani, draw it tail to tip. And when I say parallelogram method, kining letter B. When I say parallelogram method, you draw tails together. Okay? Meaning, ang ilang mga tail, imurang dikit ilang mga tail. Dili ka mag tail to tip. So for the parallelogram method. So kini, mao ni siya. Like V1 gidrawing nimong V1 diha. So this is the tail. Ya ang V2 sa dito, so imo ra pud isumpay ang tail diri V2 here. Oh, this is the tail. So tails together. Follow? And then after having tails together, you can complete the parallelogram. Let's say parallelogram, draw a parallel line to this. So na kay broken line, parallel line to this. And also parallel line to the other side during that. And then you draw the diagonal. So the diagonal will give you the resultant. And take note, it's the same resultant with a tail to tip fashion and the same resultant. Di ba? So it's just the same thing. Do not mix this up, the two. So that's the common mistake. Okay, parallelograms from the term itself draw parallel lines to the two vectors. So kung tulo na ka vector, yeah, you can do kung tulo ka vector, nga naman, na nakay resultant sa duha ka vector, di ba? And then isumpay pa nimo kung ay katulong vector nag-ana siya padong dito. So imo isumpay diri sa resultant and then mag-draw ni kag parallel sa resultant, yeah, parallel sa ana, yeah, then connect na sa kag kuan siya sa ilahang asa sila nag-tail together. Okay? The diagonal. So you can do still, but gubot siya ang parallelogram method kung more than two vectors. Okay? Pero gamit ni siya later on in our mechanics in Newton's laws. Like when we draw free body diagram. Ang kining tip to tail kay bisan pila pa na sa di kay ni siya gubot. But do not fix this up. And this is incorrect tanawa nga na incorrect man because they are tails together nya iyang gihimong diha ang resultant. So wrong na siya ha, very wrong. Okay, do not do that. Okay. So Those are the two methods in a graphical method in adding vectors. So in subtraction of vectors, it's just simple. When you say subtraction of vectors, it's just like adding the additive inverse. So like kung may kag V2 plus V1, V2 minus V1, it's just like V2 plus negative V1. Kung may kag negative V1, in this case, if this is the V, pa-up siya, pa towards northeast. So ang negative V is opposite side. Okay? So, like towards southwest, kini siya negative V. So, ma-opposite lang. Same magnitude but opposite in direction. So, it's just like kung nakay V2, nakay V1, yeah, like V2 minus V1, mao na yung V1 nga direction. Minus man siya. You can just write it as V2 plus negative V1. So, since it's negative V1, you reverse the direction of V1 in this case. Tanawa, di ba? Na-reverse. But you add plus. Okay? Plus. But the minus is already in the vector imong gi-inverse. So if you do that, you can do also the tail to tip fashion. So V2 and the negative V1, and this is now the V2 minus V1. Okay, the resultant na. Okay, so mura na siya addition actually, ang subtraction of vectors. Imurang gibali ang second vector. Any question? Wala? Wala yung pangutana? Okay. So it's part of your assignment. And multiplication of a vector by scalar. So actually, it's ang subtraction of vector is just like the second vector you multiply it by negative 1. Aron ma-opposite siya. So there, if we have to multiply by a scalar, like a number lang, like V2 is equal to 1.5V. Yeah, ang V, tanawa ning V. Ang V, inani kadak-a. Yeah, i-multiply mo siya 1.5 as much. So 1.5 as much, it will be greater in size now. So this is now the V2, 1.5 times V. Kung may kag V3 is negative 2 times V. So i-times 2 ra ni siyang size. Yeah, opposite in direction kay negative man. So this is V3. So that is just the multiplication of vector by a scalar. Okay. So aron dili mag indigestion, I will stop at this part lang. And then component method ang next nga nanay having a math, the trigonometric function, sine, cosine, tangent, and then the Pythagorean theorem, and the inverse sine, cosine. So anyway, it's part of your reading assignment. So for you to be able to interact well and makasabot ra, so you continue reading. And after this component method, my next ani, within mag-compute-compute na ta using calculator, scientific calculator, you need that. And then nanatay application, projectile motion, and relative velocity. And that's our last topic for the first quarter exam. Okay, so atong tingbon ang component method, relativity and relative velocity and projectile motion next week. Okay, and I'll be posting also this one. Okay. Any questions so far? Hay pangutana? Any question? Wala na question?